Hello, my name is Bladimir Saldaña Valdés. I am a doctoral student at the University of Concepcion, and in this presentation, I am going to show some advances of my thesis project. The main objective is to study the inundation levels of the historical predecessors of the 2010 tsunami, based on the inland extent of their tsunami deposits. We will finally propose hypothetical ruptures of the earthquakes that triggered them. The study area is located on the coast of central Chile, between the Rapel and Mataquito rivers, just in front of the zone of maximum slip of the 2010 earthquake. According to historical evidence, this area is also considered an important overlap zone between two great earthquakes of the 18th century. The earthquakes of 1730 and 1751, separated by only 21 years and with a possible geographical overlap of their ruptures. Both also generated a strong tsunami that hit the coast of Chile and Japan. Knowledge about this and other historical events is very limited and could have important implications for the seismic hazard in this part of Chile. Therefore, our research question is, what has been the size of the historical predecessors of the 2010 tsunami and the earthquakes that triggered them? To answer this question, we must first study the footprint left by the 2010 tsunami, mainly the inland extent of the tsunami deposit, which represents our modern analog. Lipimavida is particularly a good place to study due to the effect generated by the 2010 tsunami and the special geological setting that allows the preservation of the tsunami deposits. The main sedimentary input in Lipimavida comes from the nearby hills and interior basins. A possible hypothesis about the generation and preservation of tsunami deposit is that the sandy sediments taken from the beach by the tsunami and left inland are subsequently covered by these finer sediments and preserved in the stratigraphic record. Four specific objectives have been set. However, in this presentation, I will focus only on the second, characterize the traces left by the 2010 tsunami. For this, we use two main methodologies: witness interviews and remote sensing. We visited several places affected by the 2010 tsunami in central Chile, and we obtained run-up data and flow depths through witness interviews. For example, each point on this slide represents an interview in Matanzas. On the other hand, the pandemic has impeded fieldwork, and therefore it has led us to seek new methodologies. In that sense, we are using high-resolution multispectral imagery to recognize the 2010 tsunami deposit from the particular spectral signature of the beach sand, something not seen before in other tsunami studies. Thus, comparing a pre- and post-tsunami image, we can see the changes in the disposition of the sandy sediments. The normalized difference vegetation index, or NDVI, is very useful. It has been used before in tsunami-affected areas, but the novelty here is that we will use it to recognize the tsunami deposit. In addition, these results are in agreement with other post-tsunami surveys and some witness interviews. We can improve the results using other additional techniques that automate the process. For example, supervised classification. In this case, the result is more exact and we can see in more detail the retreat of the coast. Finally, knowing the extent of the modern analog has direct implications for other tsunami deposits preserved in the stratigraphic record, either to search for them or to make comparisons. This year, the goal is to generate the first scientific article about the characterization of the effects generated by the 2010 tsunami using remote sensing and witness interviews. Thank you very much.